You know, for the past couple of years, we've all been blown away by AI that can talk. But the real story, the next frontier, isn't just about talking anymore. It's about thinking. We are smack in the middle of a reasoning revolution, where AI is leveling up from just spitting out fluent language to tackling the really tough stuff, like solving complex math, writing code that actually works, and following long chains of logic. So let's dive into what that really means. All right, here's the game plan for today. We're going to break down a massive new survey that basically maps out this wild new landscape. We'll start with the revolution itself and then get into why this particular Mac is so important and so different. After that, we'll peek under the hood of the reasoning engine, touch on the big debates raging in the field, and then look at what's coming next. So what exactly is this reasoning revolution we're talking about? Well, it's the moment when large language models, LLMs, started to do more than just chat. They began tackling problems that need real logical steps. And this is a huge shift in what these models can do, and it's opening up a whole new frontier for AI. To really get this, you've got to look at how we train these things. Not too long ago, it was all about RLA traf, where models learned from what felt right to a human. Then came DPO, which was just a smarter, faster way of doing the same thing. But the real game changer, the thing that's kicking this all into high gear, is RLVR. That stands for Reinforcement Learning with Verifiable Reward. This is where the model gets cold, hard, objective feedback. Is the math answer correct? Yes or no. Does the code run? Yes or no. That black and white feedback is what's supercharging their ability to reason. And this brand new training method gives us a whole new beast, the Large Reasoning Model, or LRM for short. And look, these are not just your everyday LLMs anymore. They are LLMs that have been totally transformed by reinforcement learning. They can now plan, they can reflect, and they can even correct their own mistakes. Basically, they can think their way through a problem from beginning to end. Okay, so things are moving at a crazy pace, right? It feels almost impossible to keep up. That's why having a good map is so important. And this comprehensive survey we're diving into today, well, it's really the first of its kind to lay out the entire territory, and it gives us a really unique take on where this is all going. And here is exactly what makes this paper a game changer. You see, before this, most surveys treated reinforcement learning, RL, as just another tool in the toolbox. It was one technique among many. But this paper, it makes a really bold claim. It puts RL right at the absolute center of the story. It argues that RL isn't just a tool, it's the core engine that's pushing us towards superintelligence. It re-examines the entire field through that one powerful lens. And you can just feel the ambition here. The authors flat out say their goal is to, quote, explore strategies to enhance the scalability of RL toward artificial superintelligence. I mean, wow, they're not just cataloging what's already happened, they are actively trying to draw the map for what comes next. That's a huge mission statement. So with that in mind, let's start our tour. Let's pop the hood and see what actually makes these large reasoning models tick. What are the foundational pieces? According to this paper, it all comes down to three main pillars. First up is reward design. That's a fancy way of asking, how do you tell the AI good job? Second, there's policy optimization. Basically, what's the best algorithm for using that feedback to get better? And finally, sampling strategy. How do you come up with the right practice problems for the model to work on? You have to get all three of these right to build a really powerful LRM. Let's dig a little deeper into that first pillar, reward design. There are a few different ways to give the model a pat on the back. You've got verifiable rewards, which are super straightforward, like checking a math problem. Then it gets cooler with generative rewards, where one AI actually grades another AI's homework. Dense rewards are like a coach, giving you feedback on every single step you take. And then, the real holy grail for making this all scale up is unsupervised rewards, where the feedback happens automatically, no humans needed. And this leads us to a really important idea they call verifier's law. All it says is that the easier it is to check if something is right, the easier it is to train an AI to do it. It's that simple. And this law explains everything about why this whole revolution is kicking off with things like math and code. Why? Because they're super easy to verify. An answer is either right or it's wrong. Code either runs or it doesn't. This is the perfect automatic scalable feedback loop for teaching an AI how to think. All right, we've got the basics down. Now let's get to the juicy stuff, the controversies. This is where the real cutting-edge action is happening, in these huge open-ended arguments that are defining the frontier of AI research. So here's the first huge question everyone's debating. Sharpening versus discovery. When we use reinforcement learning, are we just making the model a little better at things it could already kind of do, just sharpening its skills? Or is it actually discovering entirely new ways of solving problems? Because think about it. If it's discovery, that means AI could come up with solutions we've never even dreamed of. The next big fight is between two different ways to teach a model after its main training is done. On one side, you have supervised fine-tuning, or SFT. You can think of that like making the model memorize a bunch of examples from a textbook. On the other side, you have reinforcement learning, RL, which is more like letting it experiment in a lab, learning from trial and error. So, which is better? Well, the evidence is starting to point in a pretty clear direction. SFT, the textbook method, often just teaches the model to memorize surface-level patterns. It gets good at the test, but maybe doesn't really understand the material. In contrast, RL seems to build real, transferable skills. It creates a deeper understanding that lets the model take what it's learned and apply it to totally new problems it's never seen before. The paper just boils it all down into one perfect, powerful line. SFT memorizes, RL generalizes. This one idea is honestly one of the biggest takeaways from this whole thing. It explains why the field is shifting so hard toward reinforcement learning. It's not about building models that can just parrot things back. It's about building models that can truly think. Okay, so we've seen how it works. We've looked at the big debates, but where is all this amazing technology actually going? Let's look out at the horizon, at the real-world uses and the huge challenges that researchers are trying to solve as we speak. And believe me, this isn't some far-off future stuff. It is happening right now. LLMs are already being used to write code, to power agents that can browse the web for you, to understand images and audio, to control robots, and even to help make new scientific discoveries. The impact is already huge, and it's growing fast. And the speed, my gosh, the speed is just insane. Just to give you a taste, look at this projected timeline of major model releases. We're talking about new, more powerful reasoning models dropping constantly. It really feels like a full-time job just to keep up with it all. But it's not all smooth sailing. There are still some massive hurdles for researchers to overcome. Think of this as their to-do list. They're trying to figure out continual learning. How do you teach a model new tricks without it forgetting the old ones? They're working on efficient reasoning, so a model doesn't use a supercomputer's worth of power to answer a simple question. Some are even trying to use RL right from the very start of training. And for many, the ultimate prize is scaling these things up to make brand new breakthroughs in science. And all of this, it brings us right back to that huge, mind-bending question from the start. This entire survey makes the case that reinforcement learning, powered by verifiable rewards, is the central engine driving this whole reasoning revolution. And if that's true, well, does that mean we're finally on the fast track to artificial superintelligence? It's a massive question, but right now, that future feels more possible than ever before.